Hi Hari, hi Murli, how are you?
Hi,
Hi,
sir.
sir.
Yeah, so how was yesterday after yesterday's class? Did you try to solve problems on binomial theorem?
Yes, sir.
Okay, so are we okay with that?
Yes, sir.
So
Binomial theorem is fine, sir. This trigonometry, some practice.
trigonometry, right? Right. Okay, okay. So what we will do, I'll make sure that tomorrow we'll do only trigonometry, okay? Because it's better to just go through all the concept once. Tomorrow we'll do trigonometry. Today we'll do the complex number assignment that I have given to you, okay?
Okay, sir.
Okay, that will I hope let others join. Okay, after
Okay.
that start. Okay, just give me 5 more minutes. I need to put my laptop and this pencil in charge. Just give me 5 minutes. You can take a 5 minutes break.
Okay, sir.
Okay. Hari and Murli, seems like nobody else is going to join, so we'll start. Okay, are you guys there?
Sir.
Yes, sir.
Yeah. What we'll do, we'll try to solve more problems based on complex number. Okay, and let's see if time permits, we'll go to trigonometry. Okay. All right. So problem number 1, complex number. Okay, so the problem is iota to the power of 198. How you will solve this? How you proceed with
Sir,
this?
I to the power
Sir,
2, then
closest multiple to 4, sir, and then
Okay. What you can write? Multiple of
Sir.
4. 4 in. Yeah.
Also do like I to the power 2, then again the whole power of 99, sir.
Okay. I to the power of 2 whole to the power of 99.
99,
That's what
sir.
you're saying?
Yes, sir.
Okay.
sir,
So what you'll get here?
We'll get -1 to the power 99, sir.
Okay. So what is this?
-1, sir.
-1. Hari, this is Hari, right? And
Yes, sir.
yeah, Murli, how you solved it?
sir, first we get it to closest multiple of 4, sir. So iota power 196 plus
196 plus?
iota power 2.
That means plus 2, right? That's how you will.
Yes, sir.
Yeah.
So,
So this is
it is
iota to the power of 196 into iota square, right?
yes, sir.
So this is going to be 1 multiplied by -1.
-1, yes, sir.
So this is -1. Both the methods are correct. See, in mathematics, it's not like there is just only one method. We can solve it using multiple methods. Okay.
Okay, sir.
Okay, cool. So that means both of you have solved problem number 1. Which problem? Okay. So second one, I guess you must have proved iota to the power of n, right? Plus iota to the power of n plus 2 plus iota to the power of n plus 1 plus iota to the power of n plus 3. So this should be equal to 0. That's what the problem was.
Sir.
I think this one is from NCERT, right? Is it? Is it there in NCERT? Have you guys tried to solve problems from NCERT after we are done?
Yes, sir.
See, you will improve yourself only when you will start solving problems. Okay, it's not like whatever we are doing in class that is enough. I'll just try to capture as much, means different types of problem, but we can't solve all the problems in class, and I think that will be enough for the concepts. Okay, so can you solve this one? Just try it. Try to make all in form of iota to the power of n. How you can write? So you can write iota to, just try this problem. Murli, have you solved this one?
Sir, I
Murli.
didn't get the right answer, sir. So I don't know.
Okay,
I
and how about Hari?
understood, sir. Sir,
Got it?
I'm doing, sir.
Yeah, so Murli, you also try to write all the terms in iota to the power of n. Okay,
Okay, sir.
do it. How can you split this term? How can you split this
I
term?
to the power n into I to the power 2, sir. I to the
Okay,
power
so-
n into I to the power n into 3, sir.
Okay, so I'll write this one. Okay, this one. So iota to the power of n into iota, right?
Yes, sir.
Is it or not? Okay,
Sir,
this
2,
one
sir.
this one I've written.
Oh, that one. Yes, sir.
Okay, so plus iota to the power of n multiplied by iota square plus iota to the power of n into
Yes, sir.
iota.
Got the answer now, sir.
Got it?
Yes, sir. It's 0.
Okay, so this always right. This is your left hand side, and now you just take iota to the power of n common. What you'll get?
0,
1
sir.
plus iota square plus iota cube, isn't it?
Yes, sir.
Yeah. Okay. Now this is your -1, isn't it? This one is -1, and this one is minus iota.
Yes, sir.
Right. So this whole will be 0.
Yes, sir.
Right. So the 0 into anything will be equal to 0. That is your right hand side.
Sir.
Yeah. Got it?
Yes, sir.
Sir, yes, sir.
Okay. What is next problem? Third one. Third problem. What is third problem? Do you guys have assignment or not?
What's
Sir,
that?
Iota to the power of 2008 plus iota to the power of 2010. It's a very similar problem that we just did.
Yes,
You just
sir.
need to take
Yes, sir.
common. Okay, take iota to the power of 8 common, 2008 common in the numerator, iota to the power of 2010 in the denominator. Take it and do it. Solve it. Tell me the answer. Both of you.
Okay, sir.
See,
Sir,
see,
I
class is
did that sum, sir.
see this class is not for solving a problem line by line. You should have done the assignment, and we could have discussed what problems you are not able to solve.
Sir,
Yeah.
I did that sum, sir.
So you got the answer.
-1 is the answer, sir.
-1. Okay, I don't know the answer. I'm just asking how you did it.
Okay, sir.
How you solved it?
Sir, I grouped whatever. So okay, sir. Okay. So that there was iota power 2008 and iota power 2012 and iota power 2016. So they were all multiple of 4. So it was 1 plus 1 plus 1, and then that way I solved it all. So
All are multiple of 4?
no, sir. Some were close to multiple of 4. So that way I got -1 and then 1 that way. Sir.
Okay. Okay, that is correct method. Again, say, Hari, how you can solve it?
Sir, I took in the numerator, I took iota to the power 2008, sir. Then,
Okay.
then after, and in the denominator, I took iota to the power 2010, sir. But after
Okay.
after taking the common out, the numerator denominator 1 plus I square plus I to the power 4 plus I to the power 6 plus I to the power 8 were common, sir. The numerator and
Okay.
denominator. I cancelled them out, and then it came as iota to the power 2008, then iota to the power 2010. So I square to the whole power of 1004 by I square to the whole power of 1005. So it will be -1 by sorry, sir. Wait, sir. Sorry. 1 by
It's fine.
-1, sir. So it will be -1, sir. Answer.
Yes, sir. Same.
-1. Both of you are getting -1?
Yes,
Yes,
sir.
sir.
Okay, good. See, the thing is, I think this question is from CBSE only. In some exam, it has been asked. So it's good that you guys are able to solve it. Okay, problem number 4. So let's not discuss this one. It's the correct. Both are correct method. It's just you don't make multiplication error, okay, or addition or subtraction, division. These, basic error. Let's not make those type of errors, and you are good to go. Okay. Now problem number 4.
Sir, 4th, I was a little confused how to do, sir.
Okay. How about you, Hari?
Sir, I have an idea, sir.
Yeah, tell me.
-1 minus I whole square by 2, sir. Then whole again full whole square by 50, sir. To the power of 50, like.
By √2, right? This is your problem.
Whole to the power 100, sir.
Okay, this is what you need to find out. Yeah. So how you will do it?
Minus I, -1 minus I, sir.
Mm-hmm.
We'll do that whole square, sir.
Okay, that means √2 can be write like this.
No, sir. Yes, sir. Then whole square, then 50, sir.
Okay. Okay.
We'll do
Next.
algebraic expressions. We'll do.
Okay. So that means this is a plus b whole square, and this the numerator denominator will be 2 only, right? You're getting Murli? See.
Sir.
Okay. Let's. He's right. Let's do it. Okay. So you can be write this -1 minus iota upon √2 whole square whole to the power 50. Is that fine?
Yes, sir. Yes, sir.
Okay. Now -1. Now this is minus a minus b whole square, which is also equal to a plus b whole square. Right? If you don't believe me, let's write it. A square plus b square, b is minus iota, plus 2 times of -1 minus iota. Right?
Yes, sir.
Is this correct
Yes,
or
sir.
not?
Yes, sir.
See properly. Is it correct?
It's correct, sir.
Correct it is. Whole divided by 2 and to the power of 50.
Yes, sir.
Okay. So this will be 1 -1. Sorry, -1, no. Iota square is how much? -1?
Yes, sir. -1, sir.
Yeah,
Then
-1 plus 2 iota, right?
Yes, sir.
Yes, sir.
Plus 2 iota upon 2 whole to the power 50.
Yes, sir.
Yes, sir.
Okay. Now this will get
Minus 1
cancelled.
minus. So it's I, sir.
Now you 2
Sir,
iota
that's
upon
I,
2.
sir.
Yeah, exactly. To the power 50. This will be iota to the power of 50. Now, what is iota to the power of 50?
I square
Can
to
you
the power
write
25, so minus 1, sir.
25? So this will be equal to minus 1. Got it? Why this is equal to minus 1, Murli, you got it?
Yes, sir.
Because this is
Understood,
minus
sir.
1 to the power of 25 and the power is odd. That's why it will be minus 1.
Yes, sir.
Okay. All right. Next problem. So option D is correct, right? Next problem is kind of similar to that. Okay. You just need to take again common and multiplication. Try it yourself. We cannot do
0,
all
sir.
the problems. Number 6, hopefully you can do.
Yes, sir. Number 6 is also zeros.
Number
6.
Number 6 is this. You have
yes,
to
sir, I got it, sir.
find real and imaginary part. So 5 plus 3. We have done this in class, right?
Yes, sir. Yes, sir.
Upon iota minus 2. How you will proceed? So this actually, listen, you have to express in x plus iota y in this form. That means
Yes,
you need
sir.
to find x and you need to find y. This is your real part. Okay. And this one is your imaginary part. Fine. Okay. Go on.
Sir, got that answer, sir. I solved it before.
Okay. How about you, Hari?
Doing, sir.
You haven't done the assignment.
Exams were going on at that time when you sent this paper, sir.
Dude, it's been 3 weeks, 2 weeks, more than 2 weeks. Okay, so how you will do it? First tell me and whether you will. Yeah.
So we can conjugate.
Sunshine. No, you have done it already, right? Sunshine, I'm asking.
Okay.
Anyone else is there in class or only you two? Okay, you two are there only. Fine. Yeah. How you will proceed for this problem? Hari?
Sir, doing, let me just.
You just tell me the process. The
Real and
procedure.
imaginary parts, right, sir?
Yeah. See, in the denominator, whenever you have imaginary part, you have to remove the imaginary part from the denominator. Okay. And for that, you will rationalize it. How do we do that?
Sir,
You just
I will multiply it by I plus 2 by I plus 2, sir.
Yes, sir. That is the conjugate. See, if Z is equal to A plus iota B, that means its conjugate we write Z bar. That is A minus iota B, right? So that's what we are going to do here. Okay. So we'll multiply it by iota minus plus 2 upon iota plus 2. Either you can do this or you can multiply it by minus 2 minus iota upon minus 2 minus iota. This also works. All right.
Yes, sir.
Okay. These both are the conjugates. So you can solve it. We'll move ahead. Solve problem number 7.
Sir,
Yeah, you got it?
for me, it's coming 1 by 2, sir.
Okay, I don't know the answer, but the process is same. You just rationalize the denominator. Okay, these two denominator. How you will do that? I'll write first step. 1 upon 1 minus iota. You just multiply it by 1 plus iota by 1 plus iota minus 1 upon iota plus 1 multiplied by iota minus 1 and you rationalize it. Okay. Yeah.
Sir, I made a mistake, sir.
Do it. Correct it. Murli, how about you?
Sir, I got the answer. I got was 0, sir.
You got 0.
Yes, sir. None of
Okay.
these.
I don't know the answer. So 1 plus iota upon, see, 1 is a square minus b square.
Yes, sir.
Fine. Minus 1 upon, sorry, iota minus 1, iota square minus, this is 1 square. Fine.
Yes.
1 plus iota whole divided by 1 minus 1. Fine.
Yes, sir.
Minus iota minus 1. This is minus 1. Fine. So
Okay.
1 plus iota upon 2 minus iota minus 1 upon minus 2. Now, since this is minus, we can take it. We can write 1 plus iota upon 2 minus will be plus iota minus 1 upon 2. Now we'll take 2 as LCM. So 1 plus iota minus 1. So minus
0, sir.
1 minus 1 will get cancelled. 2 iota upon 2. So this will be equal to iota. That means it is purely imaginary. Option B is the correct choice. Got it?
Okay, sir.
See, this is how you should proceed for these type of problems. Okay.
Okay,
To
sir.
solve problem number 8, you find the multiplicative inverse of 3 plus 2 iota. This is from again NCERT.
So can I say the answer, sir?
Yes, tell me.
Sir, it's 3 by 13 minus 2 by 13 iota, sir.
3 by 13 minus,
2 by 13 iota, sir.
okay, minus 2 by 13 iota. Hari?
For me, it's
Hari.
coming 3 minus 2 iota by 13, sir.
What do we need to find out? First, tell me that, both of you.
Sir, multiplicative
Multiplicative
inverse
inverse.
means
What
to the
do you
power
mean by
minus 1, sir.
What do you mean by multiplicative inverse?
Power of minus 1, sir.
Okay, that means if this is a complex number, z is equal to 3a plus iota b. If z is equal to a plus iota b is a complex number, its multiplicative inverse is z inverse. Okay, that means 1 upon z. That means you need to find 1 upon a plus iota b, right? Isn't it?
Yes, sir.
And now what we know that in the denominator we generally don't keep the this imaginary part. Okay, that means iota. So what we'll do, we'll rationalize it. Multiply by a minus iota b by its conjugate, a minus iota b. Fine. So in the numerator we'll have a minus iota b. Sorry, where is this? A minus iota b upon, in the denominator what we have, a square minus b square, or you can write iota b whole square, right? So this will become a minus iota b upon a square plus b square. So this will be equal to a upon a square plus b square. This is the real part, plus, minus iota b upon a square plus b square. Is this thing clear? Yeah.
Yes, sir.
Okay, so this is your real part and this is your imaginary part. Fine. So for problem number 8, you can solve it now.
Yes, sir.
If you have solved it, it's fine. Otherwise, please try. Okay. Don't expect all solutions from me. I've already given the solution, by the way. Okay. Question number 9.
Sir,
Yes.
question number 9 is doubt for me, sir.
Doubtful. Hari, how about you?
I'm doing
See,
it, sir.
this is just trigonometric function we are including. That's it. Right? 3 plus 2. You can write 3 plus 2 sine theta iota, or iota 2 sine theta, upon 1 minus 2 sine theta iota.
Sir.
Yeah.
Sir, in the question it said that 3 plus 2 sine theta iota by 1 minus 2 sine theta iota we purely imaginary means then the result should be I, right, sir?
Yeah. See, that's what I'm saying. I thought you are giving me some new information. Wait, let me write it properly. 3 plus 2, let me write 3 plus iota into 2 sine theta upon 3, okay, 1 minus iota into 2 sine theta, right? It says it will be purely imaginary, right? So if this is a plus iota b, that means a must be equal to 0, right? That's what purely imaginary means, right?
This should be equal to 1, sir.
No, b, you don't know the value of b. B can be anything, but a must be 0 to be purely imaginary.
Okay, sir.
Get it?
Yes, sir.
Hariharan?
Yes. Yes, sir.
Hari?
Yes, sir.
சுமித் சாருக்கு கரண்ட் கட்டுறா, ஸோ 5 minutes வெயிட் பண்ணுங்கண்ணா.
Yes, sir. WhatsApp message பார்த்தேன் sir.
Okay, sir.
Hi, I'm sorry. I just Bhaskar, can you make me host? Okay, thank you. So, did you guys try to solve this problem? Hari,
Yes,
Murli?
sir. Yes, sir.
Okay,
Yes, sir.
sorry. Okay, so pure imaginary means that its real part, because complex number is composed of what? See, suppose Z is your complex number, that means it is composed of real part plus imaginary part, right? So
Yes, sir.
the problem, it's already said that this real part is equal to 0, right? We don't know about the imaginary part, so we don't know the value of B. What we'll do, we'll try to express this imaginary number Z is equal to 3 plus iota 2 sine theta upon 1 minus iota 2 sine theta in a form A plus iota B. Do that. Can we do that? A plus iota B?
Yes, sir. We can rationalize, sir.
Yeah, and when you get the value of A, just substitute it equal to 0. From there, you will get the value of theta. Okay.
Okay, sir.
Yeah, Hari, try it now itself. I think both of you are having problem in this, right?
Yes, sir. Yes,
Okay,
sir.
do it.
Yes, sir.
Do it. Done. Use the same method, okay? Multiply the denominator by 1 plus iota 2 sine theta and the numerator also. Okay. Only there, or am I disconnected
Sir.
again?
Yes, sir. Doing it, sir.
Okay. So this will be 1 minus iota into 2 sine theta whole square. That means what? Denominator is anyway is going to be a real part, right? That means you need to just solve the numerator, the real part of the numerator. Okay, first solve it, then we'll discuss it. Get done? We solve this? Hurry.
Sir, is theta 60, sir?
So this you just need to multiply, right? 3 plus 6 iota sine theta multiplied by 2 iota sine theta. I'm solving the numerator, all right? Plus 4 iota square sine square theta whole divided by, this is 1 minus iota square into 4 sine square theta. Is that okay?
Yes, sir.
Now, we don't bother about the imaginary part. We just need the real part, right? A plus iota b. Let's write it in form of a plus iota b. So imaginary part is which one? Sorry, real part. This is the imaginary part. This one is also imaginary. This will be real parts. So let's write 3 plus 4 iota square is minus 1 into sine square theta, right? Yes or no? Upon
Yes, sir.
1 plus, this will be minus 1, so it will be plus 4 sine square theta plus, now again what is left in the numerator? So 6 iota sine theta, so let's take iota common. 6 sine theta plus 2 sine theta will be how much? 8 sine theta. I'm adding these two, okay, this and this. These are the imaginary part upon 1 plus 4 sine square theta, right? And in the problem, it's already given that this part is 0, right? This should be equal to 0. So just substitute. So denominator, we are not bothered about the denominator. For this to be 0, the numerator must be 0, right? So 3 minus 4 sine square theta should be equal to 0, right?
Yes, sir.
Sir,
That means 3 should be equal to 4 sine square theta.
Yes, sir.
So 3 upon 4 should be equal to sine square theta. Or if you take the square root both side, what you'll get?
root
Root
3 by
3
2.
by
sir.
2, sir.
Root 3 by 2, right? And this is plus and minus, by the way. Sine
60,
theta
sir.
should be equal to plus and minus square root of 3 upon 4, which you can
Yes,
also
sir.
write plus or minus square root of 3 by 2. Now, what values of theta will have square root of 3 by 2?
60, sir.
So theta should be equal to 60, that means
60,
pi by
yes,
3.
sir.
And we have studied that in trigonometry. And minus root 3 by 2. So this will be pi by 3 plus pi. So these are the two values. So theta should be equal to either pi by 3 or it should be equal to 4 pi by 3. Got it?
Yes, sir. Got the answer, sir.
How we got this part? Tell me how we got that part. That is important. See, that's the part of trigonometry. How? Okay. So let's see here. Sine theta is equal to root 3 by 2 plus root 3 by 2. So from here we got theta is equal to pi by 3. That is 60 degree. Fine?
Yes, sir.
Yes?
Yes.
Okay. Now sine theta should be equal to minus root 3 by 2. Right? So when it is minus root 3 by 2, let's make this quadrant system. So at 60 degree, the value is root 3 by 2 plus, right? So if you extend this in this coordinate, theta is how much? Theta is negative, so sine theta is negative in third quadrant.
Yes, sir.
So how much is this? This is 180 degree
Plus
or pi,
pi, sir.
right? So that's why we added pi here. We have discussed this in trigonometry, right?
Yes, sir.
How do you find these values? See, obviously graph is the easiest method, but what I felt like you guys, according to you, means graph is the tougher part. But the thing is, once you get to know about graphs, it will be very easy. But anyway, so you understood why 4 pi by 3 is the answer? It is
Yes, sir.
if sine theta is equal to minus root 3 by 2. Okay. Yeah.
Yes, sir.
Okay. So do the next problem, number 10. Is what? Z is equal to 1 plus iota, right? You need to find multiplicative inverse of
Z
z
square.
square. So first you will find z square, that is z into z. Okay. So 1 plus iota into 1 plus iota. Then
Yes.
you find z square inverse. That's it. Okay. Hopefully you'll be able to do it. Right?
Yes, sir. Got it, sir.
Yeah. Okay. Let's do another problem, number 11. 11 is find the square root of 9 plus 40.
Sir, 11th, I don't know how to do, sir.
Okay. So we need to find this, right?
Yes,
Isn't
sir.
it?
Yes.
Okay. Now to solve this type of problems, always understand this. You always assume this. Okay. Let 9 plus 40 iota should be equal to, this is a complex number. So let's say Z. Is that okay? Will you respond?
Yes, sir. Yes, sir.
Okay. So, or you can also assume direct, let's say this should be equal to Z. Okay. So this will be 9 plus 40 iota is equal to Z square.
Yes, sir.
Okay. Now can you find Z square? Z square is what? A plus iota. Z is A plus iota B. Right? So this will be equal to A plus iota B whole square. Right?
Yes.
So this will be equal to A square plus iota B whole square plus 2AB iota. Right?
Yes, sir.
So this is equal to A square minus B square plus iota 2AB. Fine. The value,
Yes,
that
sir.
means if you compare these, so that means 2AB, compare these two. Okay. So that means 2AB should be equal to 40 and A square minus B square should be equal to how much? 9. Right?
Oh, okay, sir.
Got it?
Understood, sir.
Compare the real part and the imaginary. Give it a try again. Okay. This is a really good problem. Okay. There are other methods also to solve it, but I prefer this one is the easiest. Okay. You just compare equation number 1 with this equation. Okay.
Got it, sir.
So you will get the answer from here. Okay. Let's do problem number 12. So again, square root of is the same method you will do. Okay.
Okay, sir.
Yes or no?
Yes, sir.
Okay, sir.
All right. Or see, again, one more method is let me write again one more method. See what you can do. Either you can assume this 9 plus 40 iota. This square root of this we need to find out, right? Should be is equal to A plus iota B. Okay, another method I'm showing it to you. Now, can we write? Okay, can we write this in form of conjugate? In form of conjugate, how we can write it? This is Z. How you will write Z conjugate?
Sir,
Minus iota B. Right?
okay, sir.
Isn't it? A minus iota B is the conjugate, no?
Yes, sir.
Yeah, and if you try to find, see, we know already Z square is equal to Z bar square. This is the property of conjugate. So from this also you can solve. You can using this method, you can solve this problem. Okay, so from here you will get not x, A square plus B square should be equal to 9 and A into B you will get 20 or 2AB you will get 40. Okay, you try it. You try this problem. It's a really good problem. I told you the method. There are 2 methods to solve. Either you use the first method or you can use the second method. Even if you are not able to solve, please ask me this. Okay, we'll see the complete solution. All right. Hari, you're there?
Yes, sir.
Okay. Okay. All right. So is there any doubt, Hari, in this? Or I can
Doubt,
explain.
sir.
No,
I can
sir.
explain again. You just need to ask me. Okay. So let's
Sir, I
move ahead.
understood.
Okay. 13. See, two methods I told you, and question number 11 and 12 are exactly same. Right?
Yes, sir.
Yes,
So
sir.
okay, express the z is equal to -1 plus iota root 2 into polar form. You just need to explain this is Cartesian form, right? You need to express this in polar form. We have done this polar form.
Yes,
But
sir.
how do we write polar form?
Sir, r of cos theta plus sin theta.
Yeah, iota. Okay, don't forget the iota. Okay,
Yes, sir.
Hari, you are aware of this? Hari,
Yes, a little doubtful answer.
okay. See, when you write z is equal to r cos theta plus iota sin theta in this form, that is your polar form. Okay. Now,
Okay,
how
sir.
do you find r? R is equal to, see, this is your a. Let's say this is x and this is y. That means z is equal to x plus iota y. So r is equal to x square plus y square. Okay.
Okay,
Yes.
sir.
Okay. And theta, so you can write tan theta is equal to y upon x. That's it. Now you already know what is x, what is y. Just convert this. Find this form.
Yes, sir.
Find this. Yeah. Do this now.
Sir, doubt, sir.
Yeah.
So when
Hari,
we do
Murli.
it, we are getting minus root 2, sir. So how can we write it in terms of tan theta, sir?
Same like we did it here. See, like we did it here in this one. I'll show you. Okay. So how much you got r, Hari?
R, sir, x square plus y square -1, sir.
-1. How you will get -1? What? Square root of, sorry, I forgot to say square root.
Okay,
Because
sir.
it is, so 1 square plus root 2 square, right? This is y, this is your x. Okay,
Sir.
that's how we write now, x plus iota y, right? So this is 1 and this is square root. Let's put a square root. So square root of, right, square root of 1 plus 2. So that is square root of 3.
Sir.
R is equal to, now tan theta. Tan theta is equal to y. Y is how much? Root 2. And x is how much? -1. So that is minus root 2. Okay.
Yes, sir.
Now you have to find theta from where. That means you need to find theta is equal to tan inverse minus root 2, right? Either you can write theta is equal to this, or do we know the where theta is equal to root 2? We don't know actually, right? When is tan theta root 2?
Yes, sir.
We don't know where is tan theta root 2. So just leave it like this. It's fine. So you can just write z is equal to r. R is how much? Root 3, isn't it? Into
Yes, sir.
cos theta. Theta is what? Tan inverse minus root 2.
Yes, sir.
Fine. Plus iota sin theta. Sin or theta is what? Let me write theta in this slide.
Minus root 2
Tan inverse minus root 2.
Okay, sir.
Okay. Got it?
Okay, sir.
Yes, sir. Yes, sir.
Is this in clear?
Sir.
I just
got
substituted theta. Here it is theta. So instead of theta, I'm just writing this value. Okay. Is that okay?
Yes,
So
sir.
this is tan inverse minus root 2. Fine. So that's how, this is your polar form. That's it.
Got it, sir.
Okay. Next problem. Next is your express z is equal to -1 plus iota root 3 upon 1 plus iota in polar form. Same problem. And modulus and argument you need to find out. I know, see, listen, Hari and Murli, both of you are here, right?
Yes,
Hello?
sir. Yes, sir.
Yeah, I understand that this is not there in the syllabus, okay? In CBSE, it has been deleted, but believe me, this is really important to find argument and modulus. What do you mean by argument? What do you mean by modulus? Okay, so don't take it as deleted. so we don't have to study, because it will create problem in your 12th standard. Okay.
Okay.
Maybe you don't want to take JEE exam and all, it's fine. We are not going to that level, but we should know if we are studying complex number, what does it mean? Okay. Okay, so let me explain you, miss. One more time I'll explain what is. So some complex number like z is equal to a plus iota y, sorry, x plus iota y, let's write. Okay, let's say this is any complex number, x plus iota y. Fine. Yeah.
Okay, sir.
Okay, so keep responding, only 2 of you are here, so we can go a little faster.
Okay.
Okay, so let's say this is the plane, complex plane. Okay. Now again, x plus iota y, what we need to do, we need to express this in polar form. Okay, so what is z? What does z represent in
Point
complex?
a point on the plane.
Yes,
sir.
this is a point in complex plane. Okay, so that means you are going x somewhere, this much is your x, and y somewhat y you are going. Okay, that means it represents this point. All right, so this point coordinate is x comma y. Okay, this is your x and this is your iota y. Okay.
Okay, sir.
Okay, so that means actually it represents a vector, but let's understand it as a point. Okay, you will be only studying it as a point, but it's a vector actually from origin to this point. Okay, now if you keep, that means this length is fixed, this length is called r. Okay, Hari, you are there? Yeah, you are
Sir.
there, right? Now this is r
Sir.
and this is theta. Yeah, in previous problem we found r and theta, right? So this is that r and this is that theta. Okay, see this we expressed in terms of complex number now. Z is equal to x plus iota y, right? And we got theta and r, right? So this is that theta and this is that r. Now the length of r will remain fixed, right? R is fixed, and r we can find using this triangle. So r will be equal to what? X square plus y square. Can we see this? In a triangle, can we see this? O, A, B.
Yes, sir.
So from in this triangle, can we write r is equal to x square plus y square?
Yes, sir.
Okay. Now, theta. From this triangle only theta, we can write tan theta. Let's write tan theta. We can find sin theta also,
Sir,
but we need to... Yeah.
Root of x square plus y square.
Root of
X
tan
square
theta.
plus-
Angle. In this triangle...
No, sir,
O,
r, sir.
Okay, R. Yeah. Okay, this is r square, no? Sorry. Yeah, okay.
Yes, sir.
R square, that means you want to write in terms of root. So let's write in terms of root. So r is equal to this. Now what is tan theta? Hari? Tan theta from this triangle, you tell me.
Sir. Sorry, what triangle, sir?
Yeah, exactly. So this is y upon x, right? Tan theta.
Yes,
Perpendicular upon base. So we got r and we got theta.
Yes, sir.
Right? So whenever we express a complex number in these forms, that is called your polar form. So in polar form, we write z is equal to r cos theta plus iota sin theta. Okay, so this is polar form. Okay, and this is your Cartesian form. This x plus iota y is your Cartesian form. Now what is modulus? Modulus is modulus of r, we write. Right, this is what you need to find out in this problem. So modulus is, in short, we write mod of z, modulus of this complex number. Okay, modulus of this complex number, it means r. Okay, that is also written as z bar, z modulus. This r we need to find out. Okay, so this is equal to your square root of x square plus y square. Okay, yes or no? Both of you?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So now argument, you need to find argument. So we write, in short, I'll just write arg of z. Okay. So argument of z is nothing but theta. All right. So we have already found theta from here. So theta is equal to what? Tan inverse y upon x.
Yes, sir.
So this is what your modulus and argument is. So now you can find question number 12. You can solve it yourself.
Yes,
So
sir.
first you express this in polar form like this we did in previous problem. And you, yeah, while solving in polar form, that means first you need to find the modulus and the argument. Okay.
Yes, sir.
Okay. Question number 15. See, z modulus is means a complex number is there. Z minus 2 upon z. Okay. So this is the complex number. Let's say question number 15. Z minus 2 upon z. Okay, is equal to 1. Then the maximum and minimum value of mod z. Okay, this is a nice problem. Okay, I want others to know this about this problem because other problems are really easy. You can solve it. Let's remind me in next class that if more people are there, we'll solve this problem. Okay.
Okay, sir.
Okay, let's not just discuss it here. I want everyone to understand this, how to find maximum and minimum value. Okay, question number, so remind Murli, you will remind me to do question number 15. Okay.
Okay, sir.
15. 16 is okay, z1 is given, z2 given, then maximum again same type of. So okay, 16 is easy. 17, sorry, 16 not 15 and 16. 17 is really easy. X minus iota y is given, so you have to, you just see this is given 17. X minus iota y is given is equal to some square root of a minus iota b upon a c minus iota d, right? C minus iota d it is given, and you have to prove x square plus y square whole square is equal to something. So what you will do, you will find this is your z. Let's say this is z. You will write z conjugate. So this will be x plus iota y, right? Isn't it?
Yes, sir.
Okay, so z conjugate you will write, and you multiply these two, z into z conjugate. Okay, and you will find it. So this you write square root of a plus iota b upon c plus iota d. Okay. So this, if you multiply 1 and 2, you will find your answer. Okay.
Yes, sir.
Okay, so just multiply 1 and 2. Question number 18. Convert complex number z in polar form. It's the same problem again. Question number 18. How you will solve this? See, you are given the complex number 1 upon cos pi by 3 plus iota sine pi by 3. Okay, it's given iota minus 1. Okay. Now what you will do, cos pi by 3 is how much?
60, sir.
Cos pi by 3 is 60. Now cos pi 60 is how much?
1 by 2. Cos 60 is 1 by 2.
1 by 2, sir.
Don't say 60. Okay. Sine is root 3 by 2.
Root 3 by 2.
Sir.
Can you write iota minus 1 upon 1 by 2 plus iota root 3 by 2? So can you write this as 2 iota minus 2 upon 1 plus iota root 3? Now you just rationalize this. 1 minus iota root 3 upon 1 minus iota root 3, right? So you'll get z from there, right? Isn't it?
Sir.
Yes,
So
sir. Yes, sir.
yeah, you find z from there and express this in polar form like we did it here. Find your argument and you find the modulus. Argument and modulus, and you write in this form. This is your polar form.
Okay, sir.
This is the polar form. In this form you can write. I suppose this is okay, this problem.
Yes, sir.
Okay. So that's how you will do. Now 19 is reduced to standard form. It's the same problem. You just multiply it, right? 19,
Sir,
do you
very
want
lengthy,
me to
sir, actually.
19 is lengthy?
Very lengthy, sir.
Okay, it's fine. It is lengthy, but you can solve it, right? You just need to fight with the problem.
Oh, yes, sir.
Okay, and see 20 is just solving this quadratic equation.
Sir, I had that one doubt, sir. So can we actually multiply root 2 in each term for both sides to because there is we
Which
can't
one?
solve,
Which
sir,
one you are saying?
first subdivision, sir.
20.
Yes, sir. 20th, sir.
Yeah, you can do that. It's fine.
Okay, sir.
Why not? See, if it is x square plus x plus 1 upon root 2 is equal to 0, right?
Yes, sir.
That means you multiply root 2 throughout if you want. Root 2 x square plus root 2x plus 1 will be equal to 0. I don't see a need of it, but if you want, because here you'll get a coefficient a, this is b.
Yes, sir.
You just get c is equal to 1, right? So why
Yes,
do
sir.
you want to do that? I don't get it. You can just directly use the roots. You can find the roots, right? Like that. You need to find this alpha and this beta.
Yes, sir.
Okay. So we'll use the quadratic formula, that is minus b plus or minus square root of b square minus 4ac upon 2a.
Yes, sir.
Okay. So we can do that. From here you will find this is just quadratic equation that we have already solved.
Okay, sir.
Yeah, you have solved that in your 10th standard as well.
Yes, sir.
Okay. Okay, I think my device is turned off. Switched off it is. What is question number 20?
Sir, this is only 20, sir. To solve quadratic equations.
Acha, this one is 20, right?
Yes, sir.
This one is 20. 19 you can try, right, Murali?
Yes, sir. 19
And
is-
Hari, okay, 21 is what?
So 21 is find modulus and argument and sketch the
20,
complex
19 as
number.
sir should do.
Sorry? Yeah. Tell me again. Hari. Hari, you are saying
21 we
something.
should. 21 we
21
should.
actually I have explained you here itself in question number 14. Right? This is what you need to do. Okay. So I suppose this assignment is done. Any doubt other than question number 15 and 16?
Sir, yes, sir. Last two question 23 and 24 alone, sir.
23, what is 23?
So if z to the power 6 is equal to root 3 plus I, find z.
Arey, yaar, it's easy, right?
Sir, it's
Okay.
little confusing, sir.
Tell me, z to the power of 6?
Is equal to root 3 plus I, find z.
Root 3 plus I.
Yes, sir, plus I.
See, this is a complex number. Let's say this is some complex number z. Okay, z already is given. Okay, let's say some complex number y. All right. Is that okay? And
Yes.
you can express this a plus iota y. Sorry, a plus iota b. Y already taken. So you get a value is equal to root 3. B is equal to what? 1.
Yes.
Huh?
Yes, sir.
Now this you can write z square whole cube.
Oh,
Let
okay.
me solve. Oh, now you got it.
Yes.
See, what you can do, either you can, this is, second method is you can find the conjugate, a minus iota b. You already have the value of a and b. You multiply the conjugate
Yes, sir.
with the value. And again, that will be equal to your z square. And you just find the cube of this. That's it. Okay.
Okay, sir.
Hari, any doubt in this?
For me, no doubts, sir.
No doubt? Okay. 20, this was 22nd, right?
23, sir.
23. 20, any other problem is there in the assignment?
Last one, 24, sir.
24 is what?
Sir, prove that if the ratio z minus I by z minus I is purely imaginary,
Z minus I by Z
z
minus?
minus I.
Huh?
Yes, sir.
Yes. Z minus I by Z minus I.
Yes, sir.
So this is equal to 1, right?
Yes, sir.
Then?
So it's saying prove that if the ratio z minus I by z minus I is purely imaginary, then the point z lies on the circle whose center is at 1 by 2 into 1 plus I and radius is 1 by root 2.
Okay, got it. See this graph. If R is always fixed, right? Radius is always fixed, isn't it? We have got R is equal to square root of x square plus y square, right? So if
Yes.
R is fixed and you rotate it 360 degree, what you will get? This is also equal to R.
Yes, sir.
This is also R, right?
Yes, sir.
So any point on a circle, like let me draw a fresh one. So if it's a circle, okay, and you have your center here, okay,
Okay, sir.
and if this is your radius R, so any point on the circle can be represented by x cos theta and y sin theta. Sorry, my mistake. R cos theta, comma R sin theta. I have explained this in class, right? And this angle is your theta. No matter what, which point you are taking. If you are taking this side, that means it is coming in second quadrant. The value of x is going to be negative. Then this will be your theta. Okay.
Yes, sir.
So it is always whenever you are expressing z, this z square is equal to x square plus y square. That means it's a circle. It's a circle whose center is at origin, because whose center is at origin and has a radius of r. Fine. No, didn't get it. Don't get it.
Sir, can you explain once, sir?
Okay, sir. No. Give me a minute. Tell me the question again.
Okay, sir. Prove that if the ratio
See, this is wrong problem because z minus iota upon z minus iota. This is always 1. It is never imaginary. It is always real.
Same doubt, because sir, they're asking us to prove that it's imaginary, sir. But it
Okay,
leads
so
to one.
I'll check this problem first. Okay, I suppose this should be conjugate, either here or here.
Okay, sir.
Okay, so with this, let me check this question number 24. Question number 15 I'll do with when everyone is present in class. Okay,
Yes, sir.
because that is really important problem.
And 16, sir.
16, yeah, 16. If I'll explain you 15, you can do 16 by yourself, right?
Okay, sir.
Okay, so with this complex number assignment is done. Hopefully all different types of problems we have done, okay, in complex number. No doubt should, if you still have any doubt in any form, argument or modulus, we can again discuss it. Hari, is that
Okay,
clear?
sir.
No, is it clear for you? Okay, with
I'm
me it
clear,
is
sir.
okay. So I'll end the class here today, okay, and tomorrow we'll meet. And tomorrow, if you want to do that, which part is there? Trigonometry. So we can start trigonometry again. Means the doubts, if you whatever doubts you have, and or else I'll start permutation and combination.
Okay, sir.
Okay.
Yes, sir.
Thank you so much.
Thank you, sir.
Thank you, sir.